Okay. So as you can see on the screen here, we have UB for UB Learns. Everything's under course document, so you don't have to look at one place. I have the syllabus like we talked about last week. The lectures may be subject to change, but the dates should generally be what they are now. And there are 7 labs. The labs are also in PowerPoint format. You can choose 5 out of the 7 labs. You're welcome to do all 7 if you want, but each lab will be worth 10 points and up to 50. So choose your 5 out of 7. I also uploaded a final project description, so a Word document kind of explaining what I'm looking for the final project that I mentioned at the first night. Obviously asked me for more clarification, so I think I really have everything other than the quiz, which I'm not going to get into. We won't have to worry about that till March sometime. I'll announce an exact date when I know when that'll be. That's the only thing not on UB Learns, so you should have all the resources you need. I'm also recording the lecture like I did last class. I recorded it, converted it to MP4, and uploaded it to UB iTunes. I'm having some difficulty getting to it. I know it's up there. Has anyone had other experiences in a class with professors using iTunes to host podcasts? Am I one of the first? All right then. I know it's on there, but I can't seem to get to it. You would go to itunes.buffalo.edu, like I'm showing here. UB Access. And it's supposed to come up with Apple iTunes, like what was on the screenshot a moment ago, but when I've been trying to load it in here, I don't see the UB welcome page. So I'm going to need, I think, to... I might, I did that. I thought this would be nice. I did that for Geo. Oh, now there it is. I might just have to resort to YouTube if this proves to be a challenge. Okay, so here we have, it came up this time. See, in iTunes we see UB College of Arts and Sciences. Huh. But I don't know where geography went. So this is strange. I mean, geography should be, it says there's 22 tracks in colleges of art and sciences. Oh. National Center. Okay, so a whole bunch of them are gone. I'm starting to lean towards YouTube. This seems to be unpredictable. And I downloaded the iTunes U app for my iPhone and couldn't find any UB applications on that. So I'm not quite sure what's going on. So stay tuned. We may switch gears and I may upload them to YouTube. That might be a lot easier than this. I mean, colleges and arts and sciences should be where that went. I did upload it. It was there. There used to be a thing where you'd click on geography. Maybe I just need to learn this better. It had all the geography courses and oh, now look, there's more. Was that there a minute ago and I missed it, or did that just show up? Yeah. So okay, so you scroll down, we see geography. You have to scroll down to the bottom, spring 2015, oh, and there it is. And there's the, this is the presentation from last week. You click get, I'm not sure what happens. We shall find out. But I was not able to get this to show up on my iPhone. So that's another thing.
It says private content. Does that maybe you have to sign in if you're UBI? Do you have to sign in with UBIs or something?
Yeah, but I think I did. Well, let's try subscribe. That could be the issue. I thought I did, but it's possible that I didn't. Okay, so we made some progress. While that's doing what it's doing, which I don't know what that is. Yeah, playing it seems to be a challenge too. YouTube. Okay. Stay tuned. It doesn't seem to be doing anything. While that's doing nothing, an update on the project drives. You have Clarence kindly added a folder for each one of you that's registered on the M drive. So you would go to M, Geography, GEO555, Student folder. I'll have one added for me too. And so you'll see your name. This is a safe place where you can put course content. You'll put your project files in there because you have write access to that location. It's not a location that will be deleted. I don't know the time frame, but a lot of data on the C drive gets wiped out on a regular basis, maybe even nightly, so don't have a heartbreak of saving data there only to have it vanish forever. Save any project, any classwork in the GEO555. I'll have other resources for the class, as we'll explain as the class goes on, in this location as well. But student folder is where your names are. If you don't appear, let me know. That might happen if you register late or something. It looks like everybody's there, but let me know if that's not the case. So iTunes update, we may switch to YouTube. We have, yeah, it looks like it's there. Thanks, Clarence. We've got on UB Learns most of the course contents available for those that want to look ahead. And we'll get started in a second with lecture number 2. I will provide more details and disseminate the quiz sometime in March. Oh, and evaluation discs for those that want to work off-site. I think that covers everything. Everyone's access was resolved, I think. That's good. Mine was too. And we'll get started. So tonight we will talk about Visual Studio 2010. Visual Studio, as I mentioned, is the programming environment that you use to build ArcObjects applications. It's not a piece of software specific to GIS, but this is a skill set, hopefully, for you that you could use outside the GIS world if you go into other programming careers. We use Visual Studio 2010 as the tools to build the Esri tool. So there's add-ins to Visual Studio that ESRI provides, and I'll talk about that. That's actually will be important if you install your own data. At 10.2, there were some questions. At 10.2, you can also use Visual Studio 2012. I'm teaching to this just because 2010 is what's still in the lab. By next semester, I assume we'll be at 10.3 in here. This doesn't affect any of you, I guess, unless you take it over. We'll probably be up to Visual Studio 2012 by next semester. But for now, we're using Visual Studio 2010 and Desktop 10.2, which is fine. So you'll find, thanks, Claire. You'll find Visual Studio 2010 on the Windows Start menu. In Windows 7, you'll often need to right-click. Starting in Windows 7, there's more user permission restrictions they call user access control than in previous versions of Windows. Given what we're doing in this course, I don't think we'll actually need to do that very often because, well, we'll talk about, most of the course we'll talk about Esri add-ins. Esri add-ins are, as I mentioned, you can add your own buttons and menus, but you can do so without being administrator, which was key to being able to teach that at UB, because the security on these machines would not, I don't think they would ever allow us to have you be administrator in a secure environment like this. So if this weren't the case, I don't think there'd be a class. And UB is certainly not unique. A lot of educational institutions, companies have similar security. When building a full Windows application, the downfall is Visual Studio needs access to the Windows registry, and they're just not going to provide that in many institutions, including here. So ESRI has come up with these add-ins as a way for users to develop still without having to have the full administrative privilege. What an add-in will do is it builds the files into your user profile. So when you log in and run in the add-in, you're able to add the buttons without modifying any Windows registry. So in other words, you don't need administrative rights. It's a kind of a long way of saying that you don't necessarily have to worry about this, but often going beyond this course, if you got more in depth with Visual Studio, you might have to do this. So I made a note of it for our lecture, even though it may not apply here. So you'll have to forgive me, I have Windows 8, not 7, so some of this is going to look a little different. So I'll open Visual Studio 2010 here. We'll see it come up. I'll go back to the slides in a minute. I'll do that now. So here's the splash screen that you'll see. So to start, in Visual Studio, we manage code in something called a project. So for example, when you start with Lab 1, you'll create a project called Lab 1. A project will encompass many different types of files that will be built into this one, but it's one project rolled up. In other words, there's different files that you'll need to create and build to create one button. We'll talk more about that. But everything rolls up into this Visual Studio project. And to create a new project, you click on the new project link on this splash screen. You'll also see, now this can get confusing. People use Visual Studio, as I mentioned, for a lot of different things. So there's a lot of different types of projects you can create. We will create what's called an ArcMap add-in. So if I go to Visual Studio 2010, new project, and I don't have it. Oh, because I've got 10.2. Let me switch. So I'm switching to, now this is the jailed machine, not my laptop. You'll see here under types of projects, there's, like I said, a million different types of projects. Websites, desktop applications, all sorts of things that you can use Visual Studio for. But you'll notice here there's a category called ArcGIS. I didn't have that on my laptop because I had 10.2. And I think when I installed the SDK, I installed it with Visual Studio 2012. I usually use Visual Studio 2012, not 2010. So switching here, the way, this is actually important, the way this gets here is there is a ArcObject SDK option when you install. You don't have to worry about it on the jail because Clarence already took care of it. If you follow along here, and you can or not, you'll notice ArcGIS is already there. But this is more important for those of you that plan on working off-site. And I will load the disk just to show you what I mean. There's 2 disks in here. Oh, tutorial data. So you'll see here, there's a specific type of project that we'll use in the course. And more specifically, it'll be the ArcMap add-in. So you'll click that. Also important, by default, the location comes up to a location on the C drive, and you'll want to change that because that's a spot that'll get wiped out every night. So you'll click Browse, and I have a slide summarizing this in a couple slides, I think. You would then, for project location, browse to your student folder on the M drive. And I don't have one. So I'll just put it here for now. So then the project that you create would be created at this location. So it's important to do that so you don't spend all night working on it, go home, and then it gets wiped out because of the security policies here. Then you would, the default name is ArcMap ArcMap add-in 1, you might call it lab 2 or something like that. So if I click OK, that's further than I want to go right now, but just to show you what happens. We've created a project with a bunch of files, all of which we'll talk about as the course progresses. But now I've created a Lab 2 Visual Studio project. And I'm going to go, I actually created it in the 503 folder from last summer. If I go here now, the project is actually stored in a folder called Lab 2. There's a solution and a bunch of different files that we'll talk about. But I just want to show you in Windows Explorer what a project looks like. So how did that ArcGIS get there? Because as I showed you, I had a problem on my machine, it doesn't show up. You have to install this item from the disk after Visual Studio is installed. So if you're installing Visual Studio 2010 and ArcGIS on your own machine, you would install Visual Studio first. So if I go to the disk, I'm going to run the disk. It should pop up in a minute. That's slow. Oh, how come you can't see that? There we go. Okay, so now this is the install for ArcGIS Desktop from the evaluation disk that I got. To install ArcGIS in general, you install ArcGIS for desktop. You'll have to do that too and follow the instructions. But specific for development, if you just wanted to use it for other classwork to make maps, that's all you would need to install. But for purposes of this course, there's this thing called ArcGIS, ArcObjects SDK for Microsoft.NET Framework. These are additional files that integrate ArcGIS with Visual Studio. So you would then, and we're not doing Java, we're doing .NET. So you would need to install this on your own machine if you want to do this. But again, after you've installed Visual Studio. If you install this first and go back and install Visual Studio later, it won't recognize it. So that's a little extra description for those of you that may want to use some of these disks remotely. Any questions? And again, I've got a bunch up here. Let me put that one back so I don't shortchange anybody. Looks like the package also has a tutorial in it. I don't think it's had that before. And the Desktop Advanced, this is the full version. That's worth quite worth 5 figures. So that's a good deal. As I said, they've always been good to students. Because now you'll learn how to use their software and go into the marketplace and tell your employer to buy more licenses. So here we saw how we're going to add an ArcMap add-in. All of the labs except in Lab 1, in our first discussion, we'll talk more just about Visual Studio and making forms. So that'll be a generic, what's called a Windows form application. But then from that point forward, we'll do ArcGIS add-ins for the remainder of the discussion in Labs 2 through 7. One thing that didn't come up here, because my configuration is already set, the first time you open Visual Studio 2010, it'll ask what programming language you want, and make sure you choose C#. And not, there's other options. There's F#, I'm not sure what that is, and there's Java, Visual Basic, and other programming languages. But the first time you ever open Visual Studio, it'll come up and make sure you, and again, choose Visual C#. I can't show you that because on both machines I've already opened it before, and that's only a one-time question. Any questions? So as I mentioned before, as I showed you before, here is a screenshot showing what happens when you create a project. It creates this folder and this solution file. We'll cover a lot of this later in the course, and solution is .sln. The file extension for a Visual Studio project that's C# is CSPROJ. You can see that here. CSPROJ. And here's just another screenshot of the various folders and files that are created, and we'll cover the structure later, I think starting some tonight and then going over the next few weeks. Oh, that's not that. I will indeed not be here next week. I had said some of these projects. I had said I wasn't going to be here for a while. It looked like I would. So I will record a lecture. I think I'll put it on YouTube just to, given iTunes, I think I'll switch it to YouTube or even put it in both places just so there's a better odds of you being able to access it easily. And I'll send out the details on my YouTube. I think I'll create a different YouTube account, not mix it with my own. So a couple of things that we cover with Visual Studio. I'm just going to create a Windows form application just to have something here. Something that you'll use, and this is what we'll do in Lab 1. Something that you use quite a bit is this Solution Explorer. The Solution Explorer lists all the files used in a Microsoft Visual Studio project. It also lists properties about the project, external library references, which we'll talk about. I don't think we get into that yet tonight, and other things. You can undock Windows. By default, Solution Explorer is on the right. Like many Windows software packages, I can drag it here and make it freeform. When I'm dragging it, you see this. It looks like Star Wars to me, this thing in the middle. I can drop it there to repin it. And if I unpin with this auto hide, it'll go away. Or you can't see that. When I do that, on the very right, there's a vertical bar that says Solution Explorer that when I click, it brings the menu back. So those are some of the general navigation options in Visual Studio. This screen also kind of summarizes that for us. How you can dock in different locations based on your preference. A lot of people dock that on the right. There's no reason why you'd have to. And so the Solution Explorer, as I just mentioned, is where various files that make up our Visual Studio project are listed for reference. So here we have a list. This is one of the lab's pictures, and there's quite a few more files in here, including references to external ESRI libraries. We'll talk about that a lot. So to start out, let's create a simple Visual Studio process and review the associated files. This is also, as I said, a good introduction. We'll start looking with the C# language. I mentioned this already, but we'll start with Windows Forms, even though we'll spend most of the course with this add-in. What I'll also do for you is when we do demos in class, what I'll try to do is load them here. I'll have a folder here, example projects. I'll have to archive all that from last year. So when we do examples, you can have that as another reference for studying, or from when you leave the class, I want to bring them with you. So I'll try to do that as much as possible when we actually go through demos, to save that for you as another resource for the course. So this, what I'm suggesting here in the slides, I actually just did. I created a C# Windows Form application on my laptop. And it said Solution Explorer shows us a variety of default files that are created for the application. And you'll notice a lot of the files end with the extension CS. That's for C#. If there's a Visual Basic programmer here, they would be .vb. So for example, it's still hard to read even at the low resolution sometimes, but that says form1.cs. So that is a file representing a Windows form, which we'll talk about in just 1 second, in C#. So you can right-click, say a Form 1 CS, and it'll say Designer or View Code. So what we see here, so I right-click Form 1 CS, and I certainly don't, everyone learns differently. If you want to play along, I'm not offended if I hear clicking and typing. Please do so. If you don't want to, won't be offended either. Do whatever works for you. If I right-click a form, I see View Designer, and when I open that, this is our very first Windows form in the class. This is not too exciting. It's just a blank box. And if I run the project, this is very preliminary. There's our first form. It doesn't really do anything. We haven't added any controls to it. But there's our first form of the course. That's called the designer, but I can also right-click and say View Code. And here's some default code behind the form. This code defines the form. So this class is where we will program what the form does. Obviously, we haven't done any of that yet, but we will. And these using statements define what libraries of code are used. System are libraries developed by Microsoft. So in other words, we don't have to write our own code that defines what a form is. Microsoft already has a thing called a Windows form, so we just reference that library. So you see using system.windows.forms. That means for our form in our library, we're going to use what Microsoft already developed. And we'll have some slides discussing this shortly. As we go on later in the class, you'll see using esri.arcgis.something. At that point, that means we're referencing Esri libraries. We're not reinventing the GIS wheel. You're using libraries that ESRI developed for us. Any questions about that? So here, okay, in this slide, so the names, I call them a library. Another term you'll frequently see used is namespace. Namespace, library is 2 examples. These are these external collection of classes and their associated methods and properties. Where we talked about methods and properties on a class the very first night. The Crow had a method and property. UB student has defined method and properties. They are stored in a namespace. So I like library. So if you think about a library as a collection of books, I like that analogy. These files are a collection of classes. And they're usually grouped into like things. For example, there is a namespace or library called esri.arcgis.3D analyst. So classes pertaining to code that you want to develop against 3D tools are all in one library. There's one called geodatabase that we'll see. So classes that are involved with accessing GIS data are all in one library. So the software developers try to group these namespaces and libraries to a common theme. And the purpose is to not load code that you don't need. Most of the time, and in this class we don't do anything with 3D. And most times you wouldn't. So why have all these classes about 3D in your computer memory that you're never going to use? This allows us to compartmentalize which libraries we need and be more efficient. Does that make sense? So by default, these are Microsoft libraries, these system libraries that are loaded when you create a Windows form application. And you can add more as time goes on. So again, a namespace is a way to organize classes with similar purpose. And by using this using statement, you're telling Visual Studio that you plan on using the classes in that namespace. Questions? When you created a project, you created your own namespace. When I first talked about namespaces, I'm talking about predetermined namespaces that were developed by ESRI or by Microsoft. But when I created this, and I did what we should never do, I just took the default name. I created my own namespace called Windows Form Application 1. And that'll certainly work. It's not really advisable. I've certainly done this. What happens a year and a half from now when you're looking through trying to find the right project and you have Windows Form Application 14, Windows Form Application 15? It's not very good from data management. So normally I would recommend you would name your project something that makes sense, like Lab 2, calculation project, etc. But here, everything that I develop against will be in my own namespace, in this case called Windows Form Application 1. And then any code associated with this class will be stored under this static class group. And as I will get to in a minute, code is grouped into these blocks. The blocks are defined with a start and stop with curly brackets. So here, see, after namespace, there's a start curly bracket, and then an end curly bracket here. Everything within that is defined as part of that namespace. Then we have a static class program. Everything defined in the program is within those brackets. That can get complicated, and it can get very complicated even under the auspices of these labs. It can get complicated when you have nested brackets. Visual Studio now tries to organize them for you with indentations, which I think is fantastic. So notice how the form brackets are indented. It did that automatically. And that makes me very happy. I never used to do stuff like that. Like, just as an example, watch what happens when I created a new if statement, which we'll talk about, and added brackets. It indented that for me. So it does its best to try to help you organize your code. One extra tip is under Edit Advanced, there's an option Format Document. If for some reason this got out of whack and they're not indented, this reformats everything for you and indents all the brackets. It doesn't seem like much now, but that's very handy if you have a 1,000-line piece of code with 20 different nested if statements. Any questions on that? And obviously that's the type of thing we'll get into much more depth on. Namespaces also help when there's ambiguity. You might have a class, two different classes developed by two different developers with the same name. So it's kind of like a last name, so to speak. That's my weird analogy of the day. I mean, if there was only one Willard in the whole world, you could always just call Willard Willard, and there would be no ambiguity because there's only one. But there's many people named Willard. So you clarify further with the last name. The namespace is kind of like a family name, if that helps make sense. So in other words, System Windows Forms might have a class named so-and-so. ESRI might have developed a class with the exact same name. So the namespace also helps us categorize things that are named the same. Now by default, this program CS was created. See, I didn't do that. When I created the Windows form, I didn't go in and type all this stuff. This program CS default was automatically created when I just created the Windows form project. You can add as many classes as you want additionally. And you'll need to do this to finish the lab successfully. By right-clicking the project, I'll show a demo of this in just a second. Right-clicking the project in the Solution Explorer, clicking Add, and then there's a variety of different items. So, in the Solution Explorer, we have the solution name, and beneath that, there's one project. In a very complicated development environment, you could have a solution with many different projects in it all combined. We don't get into anything like that in this course. But I can right-click where I have Windows Form Application 1, Add, and say New Item or New Class. Then I can name this something new, like greg.cs, and this makes a new class file. We'll see a little bit later why we would do something like this. So the new class file has a set of default references to namespaces. It has namespace Windows Form Application in it still, indicating that it's part of this solution. And now we have class Greg with empty brackets. So it's a blank slate to start writing our new class. And here's a screenshot of that. Any questions so far? So we kind of talked about this, but I'll mention it a little more specifically. What is a class? We talked about a class metaphorically. We talked about the crow and UB student, but how is that reflected in code? In code, a class is a block of code that defines our own class type and contains methods and properties. The screenshot below us, it is from this program class. C# projects by default have a program class called program.cs. There's a file in the background with that name. That's not going to cooperate. And so everything we see static class program, all the code between those brackets makes up that class program. And this is an introducing the main content. This will make more sense as we go on and actually start writing real classes and methods. You'll see their function. So here's the Windows Form application I just made. If we go into it, see there's the greg.cs file, there's the program.cs file. So they're actually text files in the background that the project uses. In Visual Basic, it's called module.vb, but we focus again on C# in this class. And here, just another slide that reinforces that. I've created a class called myName. It creates these brackets, and the code starts and ends with the brackets, and all the code associated with myName are within those brackets. A method, we talked about method conceptually again last week. A method is a grouping of code into a logical set of functionality. So by that, I mean a method should do one thing. And that one thing is an action, just like we had crow.fly, etc. Here's where you would actually program those things. DataFrame.clearSelection, and so on. In Visual Basic, we call this a subroutine. So the desired action can be called by referencing this method by name. So here the method's name is main. So if I want whatever is within main to happen, I would reference it elsewhere in code by saying main. So here, static means just one instance of the method is called for the life of the program. Without getting to that too much, we usually would put static in this class. You'll see the word void, and I should mention this main, I didn't type this either. This is a default, in a Windows application, that's a default method that gets called. You'll write your own methods a lot during this course. But void means no features are returned. A special type of method is called a function. We'll talk about that maybe next week. A void method just does something. I just say, you leave the room. There's no return action. It's like we're done with the class tonight. Go would be a method where you would just put void. There's no follow up. But if I were to say, I'm getting really abstract. Go get me a hamburger. You would go to the deli, purchase a hamburger, and bring it back to me. So in that case, instead of void, you would put in the type of class the function, the method returns. Static hamburger, method. So in that case, the method returns something, a hamburger, or a layer, or something like that. Void means nothing is being returned. And again, shortly, I can't remember if it's tonight's. I think we're going to get ahead tonight at the pace we're going. But shortly, we'll talk about methods that do return something. Hamburger is kind of a weird example just to illustrate initially what it does, but here is a perfect example that you'll actually utilize in the first lab. Let's say you have a method for converting inches to centimeters, and you'll do exactly that. You might give the method an argument saying, this is the inches, 27 inches, I want to know how many centimeters that is. You would have a method that does conversion. You would pass the method 27. It would do the conversion and then return centimeters. That's what 60, 70 centimeters maybe. So that's an example that you will use, we'll talk about shortly, where you have a method that's a function meaning it returns a value. So in that case, I could, the hamburger, presumably I would give you money. So I'm passing you an argument, $3 or whatever, $13, whatever it is. You go, the method goes off, runs to the restaurant, comes back with a hamburger. I've never used that example before. So here in this default main method, in a Windows form, that's the method that causes a form to come up. So if I open up program.cs, notice this method main, and without getting in, the first two things don't really matter, but notice it says application.run new form 1. This default method is telling us that when this project is started, open up form 1. And sure enough, if you remember a couple minutes ago, it did just that. So I've added two more methods that they don't do anything to introduce the next slide. In Visual Studio, when you have the code up, there's a handy drop-down here on the upper right that lets you quickly locate all the methods in your code file. Notice I can quickly navigate to main, greg2, or greg test. And the slide shows that too. That doesn't seem like a big deal now, but if you have a really long code file with 20 different methods, that comes in very handy. We won't have anything that long, but we'll certainly have code longer than this, and you'll see where that's a useful way to navigate. To assist in the development code, this is awesome. When I started, they didn't have anything like this. Visual Studio has a feature called IntelliSense. You know how we said, right at the beginning of the course, we said how a class has defined properties and methods? Like you might say to a crow, fly, but UBStudent doesn't have the method fly. That doesn't make any sense. Visual Studio knows that. So when you start with a class, it gives you a pull-down list of the possible methods. Very handy. So I can say, notice, so I have a new form here. When I click form dot, I get a pull-down list. These are all the possible methods and properties for a form. I'm not going in blind, in other words. and I can start by clicking R. It'll fill in for me. This is called IntelliSense, and it's very handy. It helps you debug your code too. If you type something crazy, you'll get, just like in Microsoft Word, if you misspell a word, you'll get red squiggly lines in Visual Studio suggesting that there's a problem. There's no method to a form called R, and it tells me that before I go any further. So there's another IntelliSense, and this real-time debugging are handy things as you're writing your code. I also forgot, we'll get to this shortly, but every statement in C# has to end with a semicolon, kind of like JavaScript. And notice it's got a squiggly there because I forgot to put a semicolon. It noted that for me. Like even here, when you're doing a using statement, if you've added 2 references to ArcGIS to your project, it lists them for you. Here, and we'll do this in a couple weeks, I'm starting to reference ArcGIS libraries, and it tells me which ones are available to reference. The cartographic library and then the basic ArcMap library. So what we'll do, since we're doing really, surprised I didn't add more slides to tonight. We'll finish these last couple slides. We'll start talking about variables in C#. We'll take a break. And we'll come back and I'll actually get started with some of the February 9th lecture. So then, depending how far we get into that, the recording I do for next week may include some of the February 16th lecture as well. So what are variables? I know there's not a lot of programming experience here, which is fine. But you may at least have heard of what a variable is in programming. It's a container in computer memory that's used to store information. You use variables even in math class. Do you remember coming up with intrigue math formulas? In a sense, you've already used variables in math. Pythagorean theorem, x, that's a variable. So here, x is equal to whatever those numbers are. X is a variable. So when we leap from math to computing, the variable now is a place in memory that stores x. Because presumably, I mean, we've defined this because we want to use it later. So when you issue this statement and you save x to something, in one very small spot in the computer's memory, it stores what x is for you to access later. In, that should say C# programming, not VBA. The variable can be assigned to a number of things. And we'll talk about 2 main different types of things. We call an intrinsic value, like a number or a letter, or an object, like an actual map layer or a symbol. We'll mostly talk about the former first and then get into the latter as the course progresses. So here's some examples here. There's a variable called new project. This is an example where we're referencing it with an existing variable. So the variable new project will be equal to the value of that variable times 1.08. So this would be the variable there will store a number. We'll see in C# shortly how in C# you do need to define. C# is strongly typed. You do need to define what type of thing is going to be in a variable. In some programming language you don't. So before this screen, and we'll get to that, you would need at some point to define that this variable is going to be a number. It's something that's required in C#. In this example, we're assigning a string of letters to a variable. So that variable is text, or we refer to it as a string. String is text. And when defining variables this way, we would use double quotes. This format isn't quite exactly how we do it, but this is just an example of defining a date. Or in this case, defining a variable as an object. So in that case, the layer would be the 3rd layer in the ArcMap table of contents. Variables can be read, set, or manipulated. So you can create a new variable from scratch to use. And then start with a brand new object. you can use a variable to read in an existing object. Presumably here, there already is a third layer in the table of contents. You just want to know what it is. So you're defining this variable to access an existing piece of information, or it could be a brand new piece of information. Primitive types are built-in types of data in Visual Studio. These are these intrinsic values that I said we'd be working with first. These are the most basic types of data that can be created. Intrinsics, another word I used. We'll learn more about custom types like map layers later, but we'll start with primitive types, and you see the main primitive types listed here. In general, a way to remember the difference is you can write down a primitive type. If your variable is the number 30, you can write down 30 on a piece of paper. But can you write down a map layer? Not necessarily. A map layer is more abstract. It would usually be a custom type. So primitive types are basic things that you could write down, and they generally are outside the realm of GIS. I mean, all sorts of programmers use numbers, strings, and so on. So these are the most used primitive types. Whoa. Excuse me. INT is a primitive type that represents an integer number. So it has to be a whole number. I can't believe I forgot to plug that in. So we'll use INT quite a bit as a variable type in the class. Float and double are floating point numbers that allow the decimals. Often we use double as our number value. So decimal value. Bool, short for Boolean. A bool variable can only be one of two things, true or false. We'll use that a lot. And then string is text. We saw that already. So when you declare a variable, you start out the line of code by saying what type it's going to be, space, the name of the variable you're going to choose, and then a semicolon. So here I'm defining my own new variable called myYearBuilt, and it's an integer. I'm defining my own new variable called campus name, and it's going to be a string. So string, space, campus name, semicolon. So both these cases I've created new variables. You can assign variables later, or you can assign them as a blank template. Here it's just a blank template. And then on the next line, I've set it to a number or a string. Or I can do it in C# all in one line by defining it and just putting the equals right there. Variables, I already showed an example of this, could also be assigned based on other variables or using math. That went fast. I'm going to take a break